Hi, today we are in Oracle and we're going to have an interview with the chief architect, Naci.
Very interesting character, Naci, because he's of course a technology professional, been working with technology for about 43 years, but it also is very much involved in politics as well as the arts. So he has a very rounded look when it comes to technology and its application. So we want you to join us for this session and have a little conversation with Naci and his thoughts about digitalization, the challenges currently in the market and when it comes to industries, when it comes to digitalization, and also how we could solve some of society's issues as well as business challenges as well using technology. So please join. We are here at Oracle office. This is in Lysaker, for those of you who have not been to the office before.
My name is Inaam Sheriff. I represent Media Monday, a concept that has established itself here in Oslo during the past 2.5 years, and we are one of the fastest growing technology events. And what makes Media Monday a bit special is that it is a technology event, but not necessarily for tech people, but for people who are not so tech savvy, and opening up new markets and new opportunities for cool startups as well as established corporates who are developing some amazing technology and who would like to share it with the world and make the world a better place. We are having our first video cast and with a very distinguished guest, Naci from Oracle, and he will of course will be talking to Anastasia, who is also part of Albert Bright Media, who is our media communications partner. And yes, Anastasia.
What are the current challenges when it comes to exciting industries?
Yeah, I promised before we started this that I would tell to the camera. I'm going to be cheating and I won't be looking into the camera all the time because of that. I'll have to look at my notes because I got the questions before and I have sort of prepared a little bit. I'm sorry. But it doesn't mean that I'll keep my notes. I usually don't. But still, I will look down from time to time. Yeah, well, the current challenges when it comes to existing industry, it's relatively straightforward, and I think we've answered that question many times in the past. The challenges now are keeping up with new technologies, with change. That's the main challenge, basically. And this has been the case, and because technology development has been accelerating over time while we were comfortably sleeping. Because of that, it's becoming more and more urgent. So it is the major challenge. It's not the only challenge, because there are many things happening in technology, many directions. And some of them are just buzzwords, to be honest. It's not necessarily connected to any real product or direction. It is visionary, maybe, but maybe it's not the right time for that kind of technology. So the next challenge in keeping up with change, especially technological change, is understanding when these things may be realized. Being able to differentiate between actual implementable technologies, executable technologies, and the buzzwords, the hypes. And of course, there's another one. There are certain technologies that are implementable today, like AI, artificial intelligence, machine learning, but it is also, because it has been in hibernation for the last 20 years and suddenly came back, it came back with all the old hype and added new hype. So we should be a bit careful when we start executing these kinds of technologies, not to fall into the hype hole. So that's another one. Other challenges. It's actually old and all-time challenges, continuing challenges like integration. It's still there. I mean, we've come a long way with our technologies, but the old problem of integrating data sources especially in the public sector, is still there. So that is still a challenge. There are new challenges. There is a growing, changing technology market, but the old challenges have not yet vanished totally. So we have to keep in mind that. The other one is something related to new technologies and how fast they can turn into hype. AI, for example, or machine learning. We're talking a lot about AI and machine learning these days, as much as we did just a couple of years back about big data, and as much as we did before that related to service-oriented architecture. These things go up and then sort of settle down, and then there's a new one. But the old ones do not vanish. They establish if they are real technologies. One of the things that we need to make sure we do with AI when we're going to take it into the company, into business, is to make sure that we do not reinvent the wheel, but possibly use systems with built-in AI so that we don't have to build everything in. Just an example, is a typical. Many companies are trying to program, I should call it, reprogram churning turnover. Who's going to leave the company? What's the chances of this group leaving the company? And that kind of stuff, right? But HR or HCM technologies today, some of them at least, have that built in. Why reprogram the whole thing again? So those are the kind of things that technology awareness, not only being washed away with all these new possibilities, but to see how far it has come and what is there actually. So one challenge that implies is the challenge of buyers becoming more conscious about what's actually available.
In your context, what do you mean by the hype?
Hype is not always executable, implementable. It's an innovative vision, yes, but it has the chance of becoming over-exaggerated, representing the technology as something more than it is, creating an expectation, which is dangerous, basically, because when you can't execute it the way you think it should be executed, it falls all the way out of the market, and that's not a very good thing. So being excited is good, but being realistic will help. Basically, that's what I mean by hype. The other challenge when you think of all the new technologies and the awareness that both the technical people, but also the buyers, the business people, the marketeers, everybody needs, also the politicians or whoever is on the user side of technology. That implies relatively a slightly different way of educating and re-educating people today. We have technology education that may need to be improved. That's another thing, but we need more technical people, and we need more technical people that are prepared for the market and sales kinds of roles, or decision maker roles, or buyers roles, different with a base of technology and understanding of technology, but not necessarily for implementing the technology. So there is a need for educating people not technical people, but technology people in general. Also technical people, of course. We need the guys who can use the hammer and the nail, but we need also people who can design that, who can understand the differences between two designs so that they can select the correct design and all that stuff. So education and re-education is another challenge under this changing, fast-changing, fast-paced technology.
How would you look at exciting existing industries from a true digital transformation point of view?
A very good question. So we sort of go back to this buzzword and hype stuff. What on earth do you think is digital transformation? I'd like to give an answer before you give an answer. You're all welcome to this could be a nice dialogue. But digital transformation is nothing more or less than understanding and using technology, as it is today. I mean, technology changes. It's not the same technology as yesterday, yes, but it is our capacity of understanding what exists of technology and putting it into use. Digital technology in this case. But that's digital transformation for anybody. For the technical people, for the business people, for the marketing people, for organizations, for politicians, everybody. It's a challenge that we just talked about. So that is a digital transformation.
And when it started, how do you think the digital transformation? When it started in 90s, or when was the shift of the digital transformation?
1960s.
1960s.
Yes.
So it started elaborating it.
When we had the punched card, the digital transformation started. It was much more expensive, yes, and it was much less available, but many companies started using it relatively fast. I don't know whether you know the story of IBM. It's not a real, it's partially a real story, but they say in NCR, which stands for, it's an old established company, National Cash Register. It's the abbreviation of National Cash Register. There was this guy who found this cash register that would say ping when you opened it and would count things up at the end of the day and all that stuff. He liked his alcohol, and he was used to visit a certain pub most of the time, and the guy there was very interested in this kind of technology, because then he would be able to keep track of how much of alcohol was sold, because it's not something that he can really keep track of, not that easily. So this was a nice technology for him. And he bought it, and he went to another company that was doing this kind of semi-technical stuff for business. And they started producing it. That's NCR, basically, National Cash Register. But one of the marketeers went off to another company and started another company, saying to his boss before he went out and started his own, that he was not very happy, because this was not national at all. I mean, the cash register was already very international at the time. And then there were other things that we were doing that was addressing business. So it wasn't just the cash register, it was business machines. So he said, well, we should change the name at least. And he went out and introduced International Business Machines, which is IBM. International, well, this is not fully true. It does have elements of truth in it, by the way. But you see how business and technology is married, and you see how business has been influenced. So if we're going to talk about business transformation, and I have another story, actually, if you want, how digital transformation started, or technology transformation. Digital is just one part of technology. Technology has always influenced our lives. Technology has influenced the whole world when someone found a new way of riding and shooting an arrow. Genghis Khan he took most of the world, the known world, right? So technology always influences how we live, how the societies are structured, built up or destroyed, in a sense. So it's nothing new. It's just a way of understanding and using technology. So that's what digital transformation is. Then going back to what's after defining what digital transformation is, it's just a way of understanding and using new technologies. We can say related to existing industries, because that was your question. As always, many companies, many industries are at different phases of doing this. And it all depends on how much of technology they understand, how they have built up their organization to support change, to understand change, to understand new technologies, basically. Do they have people who are actually looking beyond the next year? Or are they still jailed, as I say, into this tiny quarter? Are they looking at only one quarter at a time? It can be a problem. So that's one of the differences. People are at different phases. And it's valid for industries. Some industries are much more used to taking in technology, and that's usually technological companies. And some industries have to, and they see the cost reduction, the benefits much faster, like banking. Banking, finance is basically one computer keeping your account as a number in a computer in one memory location, right? So they need to be, it is so attached to the computer that they need to keep up with it. Yeah. And in addition, digital transformation requires muscle. So those who are capable of doing the transformation are usually those who can start these processes internally, have money and resources, But that said, startups don't have the weight of old habits and old technologies, legacy. So in a sense, some of them, the ones that are clever, actually pass in being able to apply technology, surpass the bigger guys at the start. Because they don't have anything to carry with them, they just step into the market with the new technology on board. So watch out. They are also very much the drivers in many ways. And the best example today, I suppose, is the one that fascinates me more and more, is gaming. Because nobody paid attention to gaming. I mean, we were, in my youth, we used to sit and code some games when we were tired of doing the other stuff. That wasn't really serious business. But you see how big a business it is. And if you go to, today, if you go to some of the companies that are offering gaming engines and all that stuff, you will see that they're also offering 3D visualization software and all that stuff for industries. And most of the other industries are basically taking their style and trying to put it into use. Even in education, we're talking about gamification. In architecture, in construction engineering, we're talking about gamification. So that is one of the startups that basically jumped so far ahead than the existing companies that it affected the existing companies and the market, basically.
I think one of the best examples is NVIDIA.
Yeah, right. And now they are one of the drivers of high performance computing that nobody thought of.
Exactly.
Yeah. Some technologies and some industries are better positioned for some of the for execution, basically. Not necessarily because they're better technologies or better companies, but they're just better matches, as I mentioned, like banking and finance, they need it, transport and logistics, they need it, and they can use it more or less immediately. At the moment, we had cheap IoT sensors. Transport people were on top of it. Basically, they immediately started talking about it because it gives there is a very clear benefit of doing that kind of stuff. The newer ones that haven't really picked up yet, but which I see coming is we're talking about AI and machine learning and all that stuff. But one technology that is, I mean, all digital technologies have some sort of automation and intelligence element in it. So in my world, most of them are contributing with intelligence of some sort, different levels, yes. Maybe they don't learn themselves, you have to program them, but anyway, it does contribute with intelligence. One of the technologies that contributes with very serious benefit is the hyperledger or blockchain technology. The main reason is because it is a record that is distributed and cannot be destroyed. That says a lot. I mean, I'm sure it would be a long shot and people will probably debate around it, even shoot each other in the discussions, but digital elections are possible, if you ask me. Because a paper can be destroyed easier than a hyperledger record. Simple.
Estonia is already using the digital elections, and Ukraine is already.
Yes, I know, but there are very few, and it is still in. Yes, you're completely right, and it's not really hyperledger based though, so it should be. It could be a good idea to use blockchain technologies or hyperledger kind of technologies for that kind of purpose rather than Bitcoin. It could be used as money as well. There is no reason it shouldn't be, but that's another discussion. Another technology that could have been implemented more than 10 years ago, which still is waiting, is something that Gartner has taken up recently. They call it the digital twin for organizations, DTOs. It's basically what business process management was 10 years ago when it first started to become a hype. Nobody seems to have understood how it can be used, but you can design a process, your operation, your business, in smaller processes interrelated with each other. And then you can simulate, see which one performs better, and then you can put into use the one that is better. You implement the best process for that operation. And then you can actually monitor how it actually is running by connecting every step in your process to your CRM, ERP system, HCM system, whatever. Take the data and show what it is actually doing. That's the digital twin of your operation, basically, that connects to your actual operation and helps you model your operation and simulate your operation, which is, how should I say it? I don't understand why people aren't using it, to be honest. So that's the kind of how I look at existing industries and digital transformations. People are partially aware of what's available, what's not, and we need discussions like this one, maybe more in a workshop environment, more interactive, possibly eventually, so that people sort of get there. Industries start to use more of the possibilities. That's how I look at it. Yeah, that was it.
What about governments being replaced by digital transformation? After all, it's just an admin job login all the votes of the common person.
First, we just did actually mention how they could use the politicians, the governmental organizations can use technology. Everybody can use technology. The first problem that they have to finally address is this old integration problem. That's one of the major problems of the public sector, basically, because they've developed zillions of different things that don't talk to each other, not talk to the people, and don't allow the people to talk back. This is not entirely true, because they've actually come a relatively long way, but there is still a good deal of work to be done. There was JavaZone a couple of days back last week. I wanted to talk to Origo people. I talked to Origo people. Origo is the main data center effort initiated by Oslo kommune, the municipality in Oslo, which is a very good effort. One of the things that I felt I needed to ask them, tell them maybe more, is the fact that Direktoratet for e-helse, the Directorate of e-health in Norway, has had a project going called Helsedataplattformen, the Health Data Platform, which is the same. Nav is working on similar things as well, another public institution. Diffie has been yet another coordinating public institution. I asked them why they are not doing it together, because they're trying to do the same things, basically. So yes, they are trying to integrate the databases for the municipalities, or the Oslo Commune actually, or the Oslo municipality. Why aren't they doing it for everybody and together with everybody else? So we still have this small, solve it here, don't look outside syndrome, unfortunately. So that would be a very good thing in administration, in the governmental sector. Diffie is more the national level, the Oslo Kommune is more the municipality level, but they should be able to work together. They are public services. That's one. Yeah. Yes, AI can help, I'm sure. Or forget the A part. Intelligence of sorts and digitalization of many kinds will help, because all digitalization is actually introducing some sort of automation, some sort of help, some sort of tools into the system. And of course, tools help also in governmental or in public sector, in governmental areas or public sector. Yeah. But we should be very, very, very careful with AI, because AI is a double-edged sword. And the best example is I took it from Microsoft's experiment with TAI. If the data used to train the model are biased, the model will produce a biased result. That was the conclusion of the TAI experiment. TAI was the intelligence that learned from Twitter or from conversations, tweets, basically. Just data. Nobody really programmed it. It was programmed to learn. That was the only thing it was programmed for. But what it was going to learn, they just let it read all the tweets and learn from that. And you know what happened to TAI? It became the worst hate monger and racist intelligence, if that can be called intelligence. It actually learned pretty well from all the discussions. So one should be very careful with what kind of data, how biased it is, etc., etc. So when we come to that kind of technology, AI, I keep on telling everybody, all my customers, all my people who ask me basically, that data preparation, data quality is the first step to AI. Don't forget that. That's an old technology. It's also growing and being better over time. But never forget that data management is the first step to artificial intelligence and machine learning. Never. And if I'm going to give you some percentages to give you an idea, 70% to 80% is data management in any machine learning.
To collect the data, SQL bases are important in the Oracle to organize the process of collecting the data.
That's what we call data management.
Yeah.
Yes, you have to have technology enough to access without manual intervention to a large degree, because you can't collect everything manually. So you need to be able to connect to data sources of all kinds, and you need to be able to connect to also textual and old data sources that then get translated into digital data sources, basically, and pulled in. So that's what we talk about when we talk about sort of big data kind of stuff.
And that is what is actually the Oracle is doing.
Yes.
About the databases.
I'm
They're the monsters actually in that.
Well, that's why we are focusing on data management. Basically, we do have AI and machine learning built into practically all our applications, and we do have the tools for you to build yourself. But every time I talk to people, we give them a tool. This happened. This is an actual scenario. I won't mention the customer, but we gave the Oracle Data Visualizer, the Oracle Analytics Cloud tool, with credits free to one of our customers. They pulled in data, and the visualizer didn't visualize a lot of interesting stuff. It did come up with some diagrams, yes. The data visualizer has built-in machine learning algorithms. It's not just statistics. It's not just means and averages and all that stuff. It's not only histograms and trends and that kind of stuff. But you can actually build, using the data visualizer, steps of a machine learning algorithm by pulling it from the library. You can use naive bias, or you can use classification algorithms and this and that, one at a time, or chained actually, if you want, so that you can do machine learning in the same tool without having programming skills, just drag and drop machine learning. They tried it. They were fascinated with the possibilities, but it didn't give any results. Why? They hadn't prepared the data. They didn't know which data is more likely to be related to the output they needed, and they didn't know what the question was, so they didn't know what output they needed, basically. So that is the main problem, usually, often when we are using AI and machine learning.
I think one of the things that I wanted to add, because that's something we're discussing right now, is not just the digitalization part of it, it's the strategy.
Yeah.
That's pretty important, that people understand what you can, not just understand what the technology can do, but they need to understand what they need to achieve within their organizations, what their organization goals are.
If you don't know your goal, you're not asking the question. And who can then answer? Nobody, not artificial intelligence either. So that is one of the main things. You first need to understand the questions you're asking, your goals, your strategy, if you want, and then you need to understand which kind of data, in which shapes you would need for that. And you may need to experiment with that, but you need that. That's what we call data management at large, basically. So yeah. And what am I working on? Well, I'm working practically on something that I started calling modeling, simulation, and management tools, basically. One of the reasons I'm doing that is because I see that many industries need to be able to model maybe a strategy, for example, and then be able to understand alternative strategies, alternative processes, alternative models, and be able to see what happens when things change and then be able to choose the right strategy, the right process, the right model. So simulation comes in. And then they need to be able to understand, like this DTO stuff that I was talking about, how that acts in reality. So that they need to, this model that they've chosen needs to be connected to the actual operation, so that you have a digital twin of the operation actually connected, the model, the final model connected to the real life running system operation, so you can see. And this is not only business processes, this is actually building. You can do the same thing. You can model a building in 3D using building information models, BIM. Create a 3D version of it with the right materials, the right architecture and all that stuff. Build your cables and tubing and everything into the walls in your model, okay? And then connect this model to your actual building, where you have sensors in the materials that you've used, in the concrete that you've used, for example, maybe for measuring the quality, how much it resists water leakages, maybe how it compares with other materials that you use in other buildings, maybe, and maybe use technologies like AR, augmented reality, with your goggles going into the building and seeing where the cabling is before you make a hole in the wall, right? Or if you need to change something later on, etc. I mean, you need to be able to model, check, simulate, and then connect it to the actual one. Maybe in 3D, in a business process, it's not necessary, but in a building, it may be necessary to do that kind of stuff with VR, AR, or mixed reality, or whatever.
Or even in plants, oil rigs.
Yeah. One of the things that I've been, that's the, what we call digital twins and virtual labs. That's what I'm working with. Digital twins, you understood. Virtual labs is slightly different. It's the same idea basically, but used for doing experiments that you would do in a laboratory, difficult experiments, in a virtual environment before you do it in the lab and then before you actually implement it. So we call it in virtualis. You may have heard of that. It's the another way of doing experimentation. The classical ways are in vivo, which means in life, in actual body, or in animals, basically. The other version is doing it in the laboratory, which we call in vitro, because it's in vitro is glass, in the glass, in the tube, in the lab, basically. We have been proposing and working with in virtualis experimentation, as opposed to, or as a complement to in vivo, in vitro, then in virtualis, in the virtual world, basically. Because in nanotechnology, especially because we are doing experimentation today at a level where we don't see anything, we can't even calculate most of the stuff easily. So it is much better to if you're creating nanomaterials, nanostructures with given properties, if you want to do that, then it is much easier to have a tool for doing that in a virtual world. If you can model the atoms and the relationships, how they attract each other or don't, basically, true to life models of how atoms behave, then you can actually do that in a virtual world, put those nanostructures atom by atom together, and then go to the lab and then to the production, basically. This is something that Oracle supported. That this is a, I don't know, 3-4-year-old project, basically. We supported University of Bristol first, which came out with molecular dynamics, structural chemistry kind of modeling system that then was taken over by Danish Technical University, DTU, also supported by Oracle, and they that was the proof of the pudding. They ate the pudding. Basically, they used the Bristol stuff and they created a system to answer some of the questions that has been a headache for nanotechnology researchers for the last 10 years. One of the questions was to create electronics based on carbon, not silicon, using graphene structures, carbon crystal structures, basically. This is something that's been ongoing. People have been tearing apart all possibilities, but they didn't have this kind of tool. This tool was used in DTU, and in February it was published as a breakthrough. The first time we managed to create graphene structures for electronics, basically, using this tool. And there is a video of this. I will give it to you, which discusses how they do it and all that stuff. You may probably want, it's a relatively long one, it's almost 20 minutes in itself. You may want to chop it up into pieces.
But we can also put the link.
Yeah, or
yes,
just
so
put the link. It's
yeah.
from the DTU. They filmed it. It's very interesting. And there's another link that is a link to the original research. It is a very interesting area because one of my interests, I think I've shared it with you before, is creating nanorobots for medical diagnosis and treatment, basically. This is one of the tools we needed for being able to do that. It's not the next step, I don't dare call it the next step. In about 3 steps further, or maybe 5, we'll probably be getting there using this kind of tooling. So that's what my interest is, creating virtual worlds and tools for construction engineering, for businesses, and for molecular structures, for nanotechnology. That's what I am mostly interested in today. It can be used for creating models of governmental decisions, operations. And one of the projects that we're running today, Oracle is sponsoring a student project, a European project semester project, where people are selected and come here to work from different universities. That's called EPS. European.
Here in Norway.
Yes. Together with Oslo Metropolitan University. We are looking at simulating a smart city, basically, because nobody really knows what one can do, what the limits of what one can do is in a smart. Nobody really knows what a smart city is. Mm-hmm. Smart is a very broad concept. Yeah. So we have 5 students, 2 from Germany, 2 from France, and 1 from China, working on a project we call SMACS, Smart City Simulation, basically SMACS. And we will probably be getting results by the end of this year. Very intelligent students, very motivated, and we would like to share that with municipality, Oslo at least, the roads authorities, because they are looking at, because they cannot look at the whole smart city problem. So they are reduced it to something manageable, smart mobility, and as part of it, smart rescue. Predictive rescue is what we called it, so that we get maybe the ambulance services and Vegvesenet and Oslo Kommune working together, and we have a meeting with EFE, Energy Research Institute in Norway. We're looking at that because it is related in smart energy, is part of all of that, especially in smart mobility. If you think of electrical buses charging while they're driving inductively, that kind of stuff. So we're talking about several aspects of a smart city. That's also a digital twin of a smart city, basically. Yeah, that's I think all I have to say. I think I've answered all your questions.
We have also a lot of information that you provided for us.
I think it's
The rest is up to you.
I think this is an unending conversation once
Yeah,
we start
yeah,
this.
of
So
course,
there's a
of course,
lot of
yeah.
information, and you know, we definitely look forward to your questions on the topic that we just discussed, because I'm pretty sure all of our audience have some interesting questions, either how to use the technology or a scenario that how the technology can be utilized, or how to become part of these experiments and these simulations which are going on and these projects. So I would like to end by thanking Naci as well as Albert Bright Media, and see you very soon with another interesting topic.
Thank you.
Yeah.